Welcome back to the kitchen build. This time we're going to be primarily focusing on getting this door right here actually into existence. So this door is going to look like basically a hidden member of the wall. So it's going to follow the wall paneling baseboard detail across so that when it's closed, it sort of blends in and looks like a wall. But as you walk up to it, it swings open because it's an actual door. And here's a door in the plans just to give you a better idea of how it's going to look. Baseboard's continuous across, and we have the V-groove paneling extending across the face of the door. So when it's closed, it kind of blends into the wall. And the architects did provide us with a top-down view of this, of how this is going to work out as well. So we'll have the door with some paneling attached to it, and we'll have these hidden hinges in here that actually operate and allow the door to swing into flush with the rest of the wall. And here's that hinge in real life, just to give you an idea of what that's actually going to look like. Now, one little thing I'll have to deal with is that when I set this side of the paneling detail thing, something was going on down here with the framing, and it kicked this whole bottom towards the kitchen. So now I have a twist in the framing. In retrospect, I should have checked it before I did anything and took the drywall off and furred all the framing out so it'd be in perfect alignment to this side, which I had already set, but I didn't. So here we are, going to deal with a little bit of something. So I had the laser set to be right on the inside edge of that paneling, and it's pretty well even all the way up, all the way across the top. And then as you start coming down this side, you can see it start to taper back and back as this wall starts jutting out that way. So we'll have to build in a little bit of a twist into the door, which is just an extra step, I guess. We will match the door to what's going on with the opening. So there's, of course, a lot of different ways you can make a door. When I was planning on doing this originally, I didn't think I was going to have a twist to deal with. I was going to do basically a torsion box or a hollow core style door where I'd make a webbing to go on the interior, and I would skin it with the MDF panels. That would create a door that would be a lot less heavy, but also very rigid. So you have a nice rigid door that doesn't have a whole lot of weight to it. And it wouldn't be like a normal hollow core door because the skin thickness would be the full either 1/2 inch or 3/4 inch thickness. So when you're tapping on it, it's not going to feel super duper hollow. You could also do this with a stave core and make it a solid core as well that way. But because I'm dealing with this twist, the easiest thing for me to do is going to be to laminate 2 pieces of 3/4 inch MDF together. One of those pieces we will cut the actual twist taper situation in too. So instead of making an actually twisted door, we're going to make a door that has a tapered face or tapered edge, and then the face will be all not flat. The face will have a twist to it, and it'll be variable in thickness, but I don't think you'll notice that 1/4 inch difference from top to bottom of the latch side when you're looking at the edge of the door, which you will probably never do unless you're standing in the pantry with the door open, sighting up and down the edge of the door. So this is set up with the edge here and then the top all sitting off the bed 1/4 inch on these blocks, and that's going to put this side higher. So we remove more material from here because this is the side that we want the full thickness. So that side is tacked tight down to the bed rail, and then the shims on this side gradually get deeper and deeper as you get up to the full 1/4 thickness here. So we're tapering down this way, and we're also tapering this way as well. So it's going to create sort of this like whoosh, sort of tapered effect all the way through here to make up that difference in thickness that we need. And I also put shims in the middle so that the MDF isn't sagging under its own weight. So we have a taper here in the middle as well. On the machine, one thing I'm going to do that kind of sucks, I think, is I'm going to remove this dust shroud. The kind of issue is that these whiskers, they do a really great job of dust containment, but they create such a good seal on a full surface. So if you're not hanging over the side of anything, you have such a seal on the material that there's actually some uplift from the dust collection, and I don't want the dust collection uplifting this up into the cutter head. making the cuts all kind of weird. Normally it's not a big issue with the full slab because it's so heavy, but something like this, which I guess is heavy, but it's not as heavy and big and large as a full-size slab. So I'll pop that off, and then we'll start buzzing through a few passes here to get this thing down to weird thicknesses, or one weird tapered thickness. Okay, after a quick sanding, just to kind of even things out a little bit, we're going to take a look and see how much distortion this thing's going to have, because we have disturbed the balance of this panel. And I could tell it was happening as I was going because the edges are starting to lift. So I have a lot more screws here than when I started. I was kind of hoping that it wouldn't be too much distortion. But it's looking like it's going to be a pretty good amount. So yeah, it's got pretty good, at least cup on this end. That's because this panel, if you don't remove material from both sides, it will distort because there is some kind of internal stress balance there. So in retrospect, what I probably should have done was remove 1/8 of an inch from this side, flip it over, and do the same thing on the other side with the 1/8 inch tapers, so we end up with a combined 1/4 inch taper in thickness. But what I think I'll do here, we'll see if it helps. I'm going to flip this thing over and just buzz off some material from the other side to hopefully get this a little more flat. And at the very least, we'll make it thinner so that when we laminate it to the other panels should be able to resist this extra bit of warp that this thing is going to add to the cumulative panel thing. So if I cut off my shims right where they are right now, flip it completely over, and I can use my full thickness 1/4 inch shims along that side, that should make the setup a lot easier. I'll still have to go back and set my middle shims, and for this, and I'll have to go through and screw it down basically everywhere to keep it from moving and holding it down to that actual distance off the bed. I got a couple passes on it, but I'm getting to the point now where it's getting so thin that I'm getting a pretty good amount of chatter going through here, so I think that's going to be kind of it. So down here on this end, we're at the full 3/4 inch thickness, and then up here, we'll be down at about a 1/2 inch. So in theory, that's the right amount of taper for our panel. I'm gonna clean this up a little bit with the sander, and then we can get the other piece and laminate it on here. And I guess we'll see when I take the screws out how much distortion this thing's gonna have. Yeah, that's much better. So I'm using epoxy for the glue up, I guess for two reasons. First off, this is a moisture resistant MDF, and using a water-based glue like a PVA just feels kind of weird. To me at least. I've done it and it seems like it works out okay, but I feel like maybe a non-water-based glue might be better for this material, but who knows? The other bigger reason is that I haven't trammed the head on my surfacer that well yet. So the epoxy will sort of float out any kind of variations in the surface and fill any gaps on the interior that might be there between the two panels, since epoxy is gap filling. So of course I pulled this thing out of the clamps this morning, and I already realized that I made my first mistake of this project. I had intended for this laminate to be on the other side of the one we tapered, so that when I apply the paneling to it, all the flattening marks get covered up or whatever. Now this is towards the front, and that's the actual back of the thing. So we'll have a little bit more work for the painter to make this side look nice before painting it. So I have this thing in the shop so I can install this piece of white oak that's going to give something a little more substantial for the screws to actually grab onto. I'm not too excited about putting screws directly into this MDF. Although this moisture resistant stuff feels a lot more dense, I still rather have something that's a little more, something the screws can actually grab a little better. And if we think about how this hinge is going to be installed, the reference for the install of the mortises is all going to be off the back side, and it's supposed to be set a 1/4 inch off the back face, and then it kind of ends up wherever it's going to end up in this plane. So something more like that is kind of where the mortise is going to be. And when we add the final laminate to the front, the final thickness is going to be 2 inches, at least on the hinge side. So that's going to put this thing actually centered in the thickness of the door. You can make the door whatever thickness you want. I don't really want to make it any thicker because then it gets heavier. So to make this all work out, this thing is 1.5 inches wide. So my screws will end up in this thing. So we need to make a rabbet for it down to 1/4 inch and up. This thing will set in there. It's 1.5 inches thick. So we'll have to rabbet the first laminate as well around there, which is going to be kind of nice because it'll make a nice little sandwich pocket to actually give us a lot of support and contact with whatever we're going to call it, the hinge reinforcement strip thing. I suppose there's no reason why we can't cut this rabbit onto this piece and glue it on now while we're at this. So I'm going to do that real quick. We've got plenty of time because epoxy takes a little while to cure. And with the clamps off, there is that first piece of paneling, and let's call this thing the spine, installed. Before I install the other pieces of paneling, I'm just going to give us a quick buzz on the table saw just to clean up this edge, get it all flushed up, trimmed up, and clean up any bit of the squeeze out globs on the edge. And then from there, we'll start laying in all the other pieces of paneling. I just finished a little dry assembly on here, and one of the things I did is I removed the bottom part of the groove so that I can just kind of lap these on here. I don't necessarily need these to interlock because it'll be completely glued down to the substrate, so make it a bit easier for myself than trying to actually nest all the boards together. And then I have my spacers all laid out here, so I end up flush out here, or close to flush. This still has to be trimmed down to final width. I'm a little oversized still, but I think I'm ready to go. I'm going to slap some glue all over the substrate and then lay these things in place. I'm going to tack them with some brad nails so they don't shift around left to right. And then I think we'll take this thing back out to the barn and just set it underneath some sheet goods or something just to help hold the paneling down tight to the substrate, because they do have a little bit of a bow in them because they've been sitting around for 6 months now. I've been doing this too long. Okay, the top and bottom cuts, or at least the initial top and bottom cuts, are made. The top is cut square. I checked the opening and it is mostly square. It has a little bit of a dip in the middle, but it's square if you just ignore the dip from left to right. So that side's cut square. The bottom is out by a 1/16, so the door is shorter by a 1/16 of an inch on this length. Then on this length, that at least should get us into the opening and started. I will end up scribing the floor to the door once the baseboard's in there, to make that reveal on the floor nice and perfect and consistent. But before I rip it to width, we're going to get in here and deal with hinges. So this is the setup that we're going to use to create the mortises for the hinges. So I have a 3/4 inch outside diameter guide bushing and a 1/2 inch spiral bit. So the difference between the side of the cutter and the side of the guide bushing is 1/8 of an inch. So to create a mortise, we need a pocket that is exactly 1/8 of an inch too big on all sides to create the actual mortise. So I spent some time yesterday, this is my second version of that, trying to get this size dialed in. And with this pattern here, this is the fit of the mortise or the hinge into the mortise, and that's looking pretty good. So now that I have the size of this opening figured out, I can make one template that'll do the entire hinge side and have all of the hinges mortised in one go in one template that I can use on both the door and the jamb. Okay, we've got a little sandwich thing here that just needs to get glued up. And as you can see, I have 3 hinges and there are 4 slots in here because, you know, I made a mistake. Or I made an oversight, I guess. I somehow missed the first time that they want a hinge every 20 inches, 1 hinge every 20, and then 1 for the remainder. So I would technically need 5 hinges for this. I don't really feel like buying 2 more hinges. These hinges are like $3.50 a piece. And I think I'm gonna be close enough. Okay, this thing is not fun to move. So now I need to cut my template down to width. I need the back side of the hinge to end up at a certain distance from the back of the door, specified by this drawing here. I need to be no more than 9/32 off the back of the door, and we're going to be referencing off of the face. With this template being 1/8 of an inch bigger in each dimension, I have a kind of a starting point line there. That's 1/8 of an inch from the back edge. So if I put my template on the line there, that'll show me where the front is going to end up as far as the template is concerned, right about there. So if I make a fence to align the template so that it lines up right at that line, that's going to put the back of the hinge about 1/4 inch from the back of that door. And for those of you who like math, the hinge is 1 3/8 inches wide, and we're going into a 2-inch wide door. We'll have 1/4 inch off the back, so that's going to be 3/8 off the front. So we'll be offset in the thickness a little bit towards the back. It looks like I am biased a little bit towards the back. It looks like the mortise will start basically right on that glue seam. I think that's going to work out. I'd rather be too far towards the back a little bit than needed, so I don't go too far that way, and then the door won't open apparently. So I think that's pretty good right where that is. So we can start cutting the first part of the mortise, which is going to be the thickness of the flange all the way around, and then we'll come back and put some stops in to actually cut the body, the deeper mortise for the body. But the only part of the mortise that really matters is the top part where the screws actually mount. That depth needs to be spot on, and the actual width of this thing can be a little bit too wide or whatever, because you just want to make sure that the screw area actually has some contact area on that lip that we're going to create, that step we're going to create for the mortise. So that's all set up and ready to go for the deeper mortise. The biggest issue with this is chip extraction is not that great, so drilling out a lot of material should make it a lot faster than using the router to remove all the waste. These little blocks will go to the top and bottom, and that will shorten the height of the mortise so that the router only cuts this pocket here for the body and leaves the flat areas there for the flanges. So there is the step mortise, and as you can see, I'm not quite deep enough. I'm about 3/8 of an inch too shallow. My bit's at its full plunge depth, and that's quite a bit of stick out. So I feel like I'm done with that. I could take off the template and then use a pattern bit down in here and kind of clean it up that way, which I might do. I have to chisel these corners square anyways, so I might just try one with a chisel and clean up the bottom. It doesn't have to be that clean or perfect, just gotta get the material out of there. So I'm gonna pop the template off, try to clean up the bottom by hand, and we'll see if I wanna stick that in a router and route on edge of this door. Get the doors up in the house. Here is the jig mounted to the jamb, ready to go for mortising those hinges. But before we get to that, one little side note or detour to go back to the plans. Now, the fun thing about plans is all the information you could possibly want and some information you didn't know you need is going to be in these things. So here the architect specified that the jack stud should extend past and be flush with the front of the sheetrock to basically fully contact the paneling. That's because the outside screw hole for the hinge actually ends up right between the seam of the jamb and the paneling, and if this stud here isn't the full depth of this cavity up into this paneling, the screw is going to go right into the sheetrock, which is what this section here is. So if this wasn't like this, you're just going to be screwing this hinge into the edge of some sheetrock. And of course, I didn't take heed to that. So that's exactly what is going on here. So I've already started to make a little bit of a remedy for this. I am drilling a 1-inch diameter hole, and then I will glue in some 1-inch dowels. And that'll give somewhere for the screw to actually grab onto. And that dowel will join between the jack stud and the piece of paneling here on the front. So if you look down into that hole, you can see I'm right on that piece of drywall. You can see my jack stud back there on the left and the paneling there on the right. So we'll plug all those holes with some dowels, and then we'll go through and do all the routing like normal. And then when we're done, we'll have an actual solid point for those screws to grab onto. So there it is sitting on the hinges. And one thing that happened is when I put this thing in the opening to get it to the correct elevation to get it high enough for the hinges to fully seat in the mortises, I had that little shim underneath the door. And it took a little bit to get that shim out, but when I did, it dropped down a little bit. I think everything kind of just settled into position. If there's any flex in those hinge leaves, it kind of dropped down a little bit. So everything is kind of down, and now it's contacting the floor. But at least it kind of fits in there from this point. So I'm going to take this thing back off, and we'll take a little more off the bottom, and we'll see if we can get this thing to actually sit fully on the hinges. Because right now it's on the hinges kind of, but it's like on the floor, heavy on the floor. So with a little more zipped off the bottom, now the door actually is swinging on the hinges, and I can start working on the final width. Either the door or the opening has a little bit of a bow in it, but we're contacting kind of right here, and we're kind of open down there and kind of open up here. So we're going to take this thing down to the shop and just zip a little bit off the width and try it again. There it is on the hinges, and as it's closing, we checked it at its kind of widest point, and it has a little more than a 32nd of an inch of clearance as this corner swings past the jamb. So that is kind of our final gap here, about 1/8 of an inch. And it looks like it's sitting in there pretty nicely. On that last cut, I did scribe the line from the floor onto the door, so we're going to have a nice even reveal here on the floor. The floor pops up a little bit as the door swings into the opening, so there's a little more material removed on here than I was planning originally, but at least it's nice and consistent now. So last thing, now that's actually in here on the hinges and everything, is transferring this line of the baseboard onto the door and then getting the baseboard installed at exactly the right place. The baseboard's attached, it just needs to be flush trimmed. You can see the difference in thickness as you go from the thin side to the wide side, and I started getting the back side faired so it's ready for paint. So while I am routing, I will also go ahead and cut some faux V-groove handling look type thing into the back of the door so that when you are in the pantry and the door is closed, or when you're looking through the pantry window while the door is closed, the door resembles the paneling that's in that room as well. Before I do the final test fit on this, I want to have the other hinge that's going to come in a few days. So I'm going to get started priming this side and getting it leveled out and ready for top coat, so it's at least behind me and done. But I thought I'd touch on handles real quick. So this is the handle that we have for the front of the door. That's the same handle that's going to be on the refrigerator. And the idea there is that as you are pushing the door open, it gives you something to grab that's relatively easy to clean instead of getting your fingerprints all over this door. So that's on the outside. Now on the inside, you definitely need something to pull that door back open, because without a handle, you are effectively locked in the pantry. Now this handle is a through screw, so on one side you're going to see the screw head. I don't really want to see the screw head on the reverse side of this door. So one thing that is out there you can do is you can get a back-to-back style handle hardware set, or whatever you want to call it. The through bolt one still gets bolted through, but instead of a screw like this, they have a stud on the end that has a bit of a V-channel cut in it. And then on the mating handle, instead of being threaded, it has a larger hole that slips over that the head of that bolt. And then there are set screws that you tighten that actually locks the back handle to the front handle. So once all together, you don't see any hardware except for the set screws that you typically set on the bottom, or like on one face. So as you're looking down at it, you don't see any of the holes. So that would be kind of the ideal option. I don't really care if the back handle is exactly like this, but the problem I'm having is that this is not a standard hole spacing, so all of the back-to-back handles you can buy to go with those hardware sets don't fit on the spacing, so I'm kind of at a loss on that. This is a 12.5-inch spacing, or was it 320 or 340 millimeters, and all the other ones are a standard 12-inch. So for the back side of this, what I have come up with is I'm going to get a second one of these, and I will create a mounting plate for it. So what I think I'm going to end up doing is I will get a piece of stainless steel bar stock. This is just a scrap piece of mild steel, and I will drill mounting holes into the bar stock to screw the bar stock to the door, and then on the back side of the bar stock I will through bolt this guy with some really short screws. So this is mounted to the plate, and then the plate is mounted to the door, and that's directly over top of the holes for the hardware to hold the front handle on. So that's at least the plan. I won't be showing that in this video because that'll be something I'll do in the future when I'm more closer. Well, when I'm further along, so I gotta go buy some stainless steel now. But that's sort of the plan I have right now for the handles. Let's get this thing sprayed, and then we can do the final test install and wrap up this video on this twisted panel hidden door thing. And here is the final look of the door with the baseboard installed. You can see it got a nice consistent gap along the floor. Looks really good. One thing you'll notice is the gaps on the left and right aren't consistent. On this side, the gaps are tiny. I set the depth of the mortises a little bit deep so that when I come back and paint and there's some paint and crap in there, that should push this side over a little bit, open this gap up, and kind of even things out a little bit. But otherwise, that's how it fits in there, and it looks pretty darn good. Surprisingly, this worked out really well. It's really, really close. The top is just a little bit out towards the room a little bit, but as you look down the door this way, it's pretty darn near flush at the bottom. So putting that twist into the door really worked out, and it actually looks really good as you come and get in plane with it. There's what it looks like on the inside. Nothing too crazy, but I think having those V-grooves in there just give it a little bit more visual interest as you're looking in here through this window thing here. So that's where I'm gonna end this one. This door can go off to paint. It'll be a few weeks to get this door through paint, and in the meantime I have to paint this whole room anyway, so we'll do the final install in a future video. There is our hidden pantry door thing. My first time making a full-size door that a person can walk through. Every other door I've made has been, you know, furniture or cabinet size. So the first time making a door with concealed hinges and a twisted opening. Feels like jumping in to the deep end. So that's gonna do it for this one. Thank you as always for watching. I greatly appreciate it. If you have any questions or comments on this weird door or anything back in the shop, please feel free to leave me a comment. As always, I'll be happy to answer any questions you might have. And until next time, happy woodworking. Twisted door thingamajiggy.